Welcome to Riot Tuition Classes. We are doing a revision series of physics numericals. I'm on lecture number 3. I told you children, I'll be giving you some 10 lectures. And if you go through these 10 lectures, okay, it's just a last minute revision of the physics numericals. I'm sure children, it will help you to increase your confidence. So this is the third lecture of it, okay? The refractive index of a glass with respect to air. Refractive index of glass with respect to air. See here, children, refractive index of glass. First, they say glass and then they say air. Pahla glass bola. Refractive index of what? Glass with respect to air. So, see how it is written. Refractive index of glass with respect to air is how much they're giving children? 1.5. Okay. And what they want, what is the value of refractive index of air? Abhi air pehla aa raha hai upon refractive index of glass. So don't you agree, children? Here, refractive index of glass with respect to air, and here refractive index of air with respect to glass. Got it? So here, children, please have a look here. In the first one, refractive index of glass with respect to air. Refractive index of glass with respect to air. The ray of light is coming from air to glass. The second one में refractive index of air with respect to glass. मतलब the ray of light is coming from glass to air. ये दोनों उल्टा हो रहा है. इधर क्या हो रहा है? Air से glass में आ रहा है और इधर क्या हो रहा है? Glass से air में आ रहा है. So naturally, whenever you come across such a question, remember, children, they are reciprocals of each other. So refractive index of air with respect to glass should be 1 upon refractive index of glass with respect to air. So how much you get, children? This is 1 upon 1.5. This is nothing but 10 upon 15. So how much you get? 5 2s are, 5 3s are. So refractive index of air with respect to glass, when you divide 2 by 3, 0.666, that is, it goes on recurring 0.67. So answer, I'll write the answer. I always told you children, you should always write the answer with respect to the question, the way it is asked, okay? So what is the answer, children, here? The answer will be refractive index of, this is the answer I'm writing to the right hand side, refractive index of air with respect to glass, with respect to glass. Glass is what, children? We got it as 0.67. Okay, this is the answer. Are you getting me, children? So remember, children, very simple question. Okay, it can be any two mediums. Okay, जैसे इसमें पहला इसमें एयर से ग्लास में जा रहा है, दूसरा इसमें ग्लास से एयर में जा रहा है. जब एयर से ग्लास में जा रहा है तो रिफ्रैक्टिव इंडेक्स जो कैलकुलेट करते हैं उसको रिफ्रैक्टिव इंडेक्स ऑफ ग्लास विद रिस्पेक्ट टू एयर बोलते हैं. और जब ग्लास से एयर में जा रहा है, रिफ्रैक्टिव इंडेक्स व्हेन यू कैलकुलेट, इट इज एयर विद रिफ्रैक्टिव इंडेक्स ऑफ एयर विद रिस्पेक्ट टू. So when you see any two mediums of this way, okay, they are reciprocals of each other. Are you getting me here? I'm sure everybody understood how the answer I got, okay? So we go to the next sum, children. Pretty simple sum. We go to question number 2. Children, very simple sum, and understand this sum. This type of sums are asked in the exam, okay? A coin is placed at the bottom of a beaker. Actually, coin is placed at the bottom of the beaker. This is the actual coin, actual position of coin, actual position of coin. I should say actual position of the coin, okay? I should call it as actual position of coin, okay? Position of coin. Now, this coin appears to be raised up by 4 centimeter in the water contained in the beaker. There's water contained in the beaker. This is the actual position of the coin. And this coin appears to be raised up, okay, by 4 centimeters. That's why I just call it as an apparent position of the coin in water, okay? Now, if the refractive index of water, actually, what is the meaning of refractive index of water? It is refractive index of air with respect to, refractive index of water with respect to. Matlab, the ray of light is coming from air to water. Are you getting me here? So, solution, please have a look at. This is refractive index of refractive index of water, water with respect to air. By default, they'll only say refractive index of water. But you should understand, by default, it is refractive index of water with respect to air. This is always 4 upon 3 they are given, okay? It will always be greater than 1. Air, water with respect to air. Now look at children. They say the real depth, if they find the depth of water in the beaker, that means the real depth they wanted to find. And the water, this coin appears to be raised up by 4 centimeters. So see, my method, there is a formula, direct formula for doing it, children, but I always follow this method, okay? Real depth, please have a look here. Real depth is nothing but actual depth of water. We don't know this. So what I'll do, let real depth equal actual depth of water be equal to x centimeter. Okay. Now listen, this coin appears to be raised up by 4 centimeters. That means what is the apparent depth? Therefore, apparent depth, apparent depth equal. See, sorry, I better say like this. The coin appears to be raised up by the coin appears to be raised up by the coin appears to be raised up by 4 centimeter. Appears to be raised up. Appears. Actually नहीं होता है लेकिन appears है. Therefore इसको बोलते हैं apparent depth. Therefore apparent depth equal of coin equal x minus 4. पूरा x है लेकिन 4 centimeter appears to be raised up है. So naturally x minus 4. Now remember refractive index of water with respect to air is also given by the formula real depth upon apparent depth. So what is it, children? You know the values? So what will happen? If I substitute the values, I'm just rubbing it off, children here. Okay, I'll just write it here. Okay. So therefore, here, I'm going to write it here, children. I'll just show it separately. Okay. I'll just show this part separately. I'm going to do the sum here. In this box, I'm going to continue the sum in this box, children. So please try to understand it, okay? Let's not get confused. Very simple sums. Okay. So real depth, what is this? Refractive index of water with respect to air is 4 upon 3. 4 upon 3 equal, real depth is x upon apparent depth is x minus 4. So now what will happen? Cross multiply 4 into x minus 4 is equal to 3x, children. So 4x minus 16 is equal to 3x. So 4x minus 3x is equal to 16. So x equals 16. Got it? So they are saying find the depth of water in the beaker. Therefore, real depth is nothing but depth of water in the beaker. Depth of water in the beaker, equal real depth. How much it is, children? This is nothing but 16 centimeter. I hope everybody understood this sum, children. I know little extra space also required, so I've done it in a side. I'm sure everybody understands it. Not a difficult sum at all. A very simple sum, children. But surely as in your exams. We go to a very simple question, children. Looks like a lengthy question. Many of the children, they read it and they don't have patience for reading it, okay? They try to read it and don't have patience for reading it and they think this is a difficult sum. But it's a very simple sum, children. Very easy sum. A music system draws a current of 400 milliampere. So I is 400 milliampere. Now here I have seen many children getting frightened. Remember, children, ये मिली यूनिट जब भी रहता है, मिली यूनिट, सी यूनिट इज एम्पियर हियर, milli is a word, milli ampere, milli unit. Milli unit is nothing but 1 upon, milli is 1 upon 1000 of the unit. Remember, कुछ भी मिलीग्राम, मिली जो भी वर्ड आता है, मिली, मिली इज 1 upon 1000, मिलीलीटर, गॉट इट? तो याद रखो, मिली वर्ड इज 1 upon 1000. तो ये क्या हो गया बेटा, ये मिली निकालना है, क्योंकि SI unit is ampere. My calculation should be in amperes if I want to do it, okay? So naturally, what I do, 400 divided by millis, 1000 children. So it becomes 400 upon 1000 ampere. Now you can see here, two zeros get cut. So it is 4 upon 10. So 4 upon 10 ampere. Got it, children? Now look here. They are saying a music system draws a current of 400 milliampere, which is nothing but 0.4 ampere. When connected to 12-volt battery, V is 12 volt. V is 12 volt. Now, what is the resistance or resistor? What is the resistance of the music system? Resistance word, children, of the music system बहुत बड़ा लगता है, डर लगता है, अरे लेकिन रेजिस्टेंस हम लोग को मालूम है, ओम्स लॉ, रेजिस्टेंस का फॉर्मूला क्या है बेटा? R is V upon I. R is V upon I. Ravi, R-A-V-I. R is equal to V upon I. Got it? Ravi, नाम से याद रखो बेटा. R is equal to V upon I. Okay. Now this is V is how much, children? 12 volt, okay? And how much is I, children? 4 upon 10. You know, what is the meaning of it, children? 12 divided by 4 upon 10. तो आपके छोटी क्लास में आप लोग ने सीखा है डिविजन मतलब क्या है? 12 multiplied by reciprocal 10 upon 4. 4 one time, 4 three times. How much it becomes? 30 ohm. 30 ohm. So yaad rakho children, R is 30 ohm. Now, the B part. The B part is very interesting, children. Again, such a big one. Children will think, ये क्या है? Okay. अभी याद रखो, ये म्यूजिक सिस्टम का रेजिस्टेंस 30 ओम्स ही रहेगा, स्टैंडर्ड. ओके, बाकी सब वैल्यूज चेंज होएगा, लेकिन रेजिस्टेंस उतना ही रहेगा म्यूजिक सिस्टम का. So now let's see the B part. The music system is left playing for several hours. Oh, and finally the battery voltage drops and the music system stops playing when current drops to 320 milliampere. Now the current has become 320 milliampere. And that time, 320 milli, तो वापस हम लोग क्या करेंगे? 320 upon milli मतलब 1000 ampere. 0 cut. So you're left with 32 upon 1000 100 ampere. Okay. Then they're saying, what is the voltage of the music system? V is how much? I1 is so much and V1 is how much, children? Got it? The same question it is. So remember, children, such an easy one. Okay. I'm doing it as a side, children. Just have a look here. Okay. I'm just rubbing it off. This milli word, you understand the meaning of milli unit. Okay. So now I'm just doing it to the side of it, children, just completing this sum. Okay. So now I want one thing I told you, children, if you remember, I told you in resistance of the ear music system, क्या रहेगा? 30 ohm ही रहेगा. अभी I1 कितना है? 32 upon 100. V1 is how much? We don't know. So, you know, children, you know the formula, Ravi, R is equal to V1 upon I1. You want V1, children. So, V1 equal I1 into R. Are you getting me a cross multiply, children? V1 equal I1 into R. So, what is I1? I1 is 32 upon 100, okay? And what is the resistance given? It is 30. So what happens? 0 cut. 96 upon 10 is 9.6 volt. That means when V1, what is the voltage of music system when it stops playing? So music of sorry, the voltage of music system is 9.6 volt when it stops playing. Voltage of music system is 9.6 voltage when it stops playing. When it stops 9.6 volt when it stops playing. When it stops playing. This is the answer, children, what I have written here. Okay. Now I'm sure, children, people have understood it. Okay. Don't think this is a difficult one. Okay. This is a simple one. Okay. Not a hard one at all. Okay. Sure, children. We go to the next sum, children, now. Question number 4. A cell is sending current in an external circuit. How does the terminal voltage compare with the EMF of the cell? Now, this part of the question, that is the A part of the question, is nothing but a theoretical question. So see that. I'll just tell you here, the EMF of a cell is the total energy that a cell can give to move a unit charge through one complete round of an electrical circuit. Now, what I mean by one complete round is, please have a look in your mind. Okay, suppose it starts from positive terminal, passes through these conductors, wires, okay, passes through these conductors, and again, children, comes back to the negative terminal, and then through the, please have a look here, through the cell, it again comes back to the positive terminal. That is one complete round of an electrical circuit. Okay. So this is, please understand, this energy, that is EMF of the cell. So EMF of the cell is the total energy that a cell can give to move a unit charge through one complete round of an electrical circuit. Whereas, okay, your terminal voltage is what? The energy used by the cell to move a unit charge to the external part of the circuit, that is to the wires in the circuit. Right. So when it starts from the positive terminal, the charge passes through these wires, and comes back to the negative terminal. So only from the positive terminal till negative terminal, what energy the cell will use up, that is called terminal voltage. So naturally, terminal voltage will always be less than the EMF. Terminal voltage will always be less than the EMF when the cell is working. When the cell is working. And when the cell is off, no current is passing. Terminal voltage and EMF are the same. Are you getting me? A terminal voltage EMF are the same. But here I just written the answer to the point. Okay. Now I start with the B part. 3 resistors are connected to 6-volt battery as shown in the figure alongside. Got it? You can see 8 ohm, 12 ohm, 7.2 ohm. मैंने बताया जब भी ऐसा सर्किट रहेगा, नेटवर्क रहेगा, जहां गर्दी उधर से सिंप्लीफाई करने को स्टार्ट करो, तो ये दो रेजिस्टर्स पैरेलल में है, 8 ohm and 12 ohm. इसको सिंप्लीफाई करो. So I'll just write the resistors 8 ohm and 12 ohm are in parallel, and let RP, resistance in parallel, P for parallel, let RP be their equivalent resistance. Okay. Now what will happen, children? You can see here 1 upon RP is equal to 1 upon 8 plus 1 upon 12. What is 1 upon 8 plus 1 upon 12? So what is the LCM of 8 and 12, children? 24. So what is the LCM of 20? Please have a look here. 8 and 12 both divide 24. 24 is LCM. So this 8, I want to make it 24. 8 has become 24. 8 has become 24. 8 has become 24. लेकिन 8 कभी 24 बनेगा जब 3 से मल्टीप्लाई करूंगा. तो ऊपर भी 3 से मल्टीप्लाई करना पड़ेगा. 1 into 3, 3 plus 12 has become 24. 12 has become 24. 12 कभी 24 बनेगा जब 12 को 2 से मल्टीप्लाई करूं. तो ऊपर 1 को 2 से मल्टीप्लाई. Are you getting me here? So 1 upon RP is equal to, children, how much it is? 5 upon 24. So what is RP equal? RP equal 24 upon 5. That is nothing but 4.8 ohms. Now, please have a look at. Now, RP and 7.2 ohms are in series. Let R be their equivalent resistance. R be their equivalent resistance. R be their equivalent resistance. So what will happen, children? 1 upon R, R, it's a series. R is equal to RP plus 7.2. RP is how much, children? 4.8 plus 7.2. So how much you get? 12 ohms. Or we got 12 ohms. Now they want total current in the circuit. So what did I find? I found out total resistance of the circuit. But I want total current. Now we know, children, EMF of the cell is 6 volt. EMF is 6 volt. EMF equal 6 volt. Okay, 6 volt. Sure, children. Got it? So what is total current? I is equal to, please have a look here. I'll put it like this. I is equal to, because there is no internal resistance provided here, I'm not going to worry about the internal resistance. I is equal to, okay, see, R is V upon I. R is V upon R. I is equal to V upon R. So I is equal to E upon R. Why I take E upon R, children? They are not given any internal resistance. Now, E is how many, children? This E is EMF 6 upon, what is the total resistance? 12. So how much you get, children? This is 6 ones are 6 twos are. So 0.5 ampere. What is the total current? 0.5 ampere. What is the total current? 0.5 ampere. What is the total current in the circuit, children? 0.5 ampere. This is the B part. Now, what is that? C part. Put the total current in the circuit. I'll just write total current 0.5 ampere. Now, look at this C part, children. PD across 7.2 ohm resistor. Potential difference across 7. So, what current is passing through it? 0.5 ampere. So, naturally, very simple, children. I want V across. I'll just rub this part, children. This question number 4. I'm so sorry, children, but I don't have place left out to solve it, okay? So, I just rub the first part, A part of the question, okay? Now, what I want, children, I want the C part of this question, okay? What it says, C part says, what PD across 7.2 ohm resistance? PD across, matlab R is 7.2, the current that will pass across, this is 0.5 ampere. So naturally, V is equal to, this V is nothing but PD across 7.2 resistor is V is equal to I into R, children. So what is this? 7.2, sorry, I is, R is 7, so 0.5, I is 0.5 into 7.2. So how much you get? 1 upon 2 into 7.2, 7.2, sorry. 1 upon 2 into 7.2. 1 upon 2 into 7.2. So what will happen, children? 1 upon 2, 0.5 is 1 upon 2 into 7.2. So it will become 3.6. What it will be? 3.6 volts. So V, potential difference across PD across 7.2 ohm equal 3.6 volt, children. So this is the C part ka answer. I hope everybody's understood this question, children. Not a difficult question. We have to write a lot, but it's an easy part. Okay, children. We go to the next. A nucleus, sodium, atomic mass number 24 and atomic number 11 emits a beta particle. Beta particles, beta particle. Okay, to change into magnesium. Write symbolic equation of nuclear process. So see the answer of the first one. Sodium, I write always atomic mass number also to the left hand side. Atomic mass number 24, atomic number 11. It gives a beta, emits a beta particle. So what is law of beta emission says? The atomic mass number will remain the same, but the atomic number increases by 1. So atomic mass number is 24, it should remain the same. And atomic number should increase by 1. So 11 plus 1, 12. It becomes magnesium. And it is given out an electron. Electron is nothing but a beta particle. Okay, I can also put it like this. Now, what is the second answer? What are the numbers 24 and 11 signify? 24 signifies the atomic mass number. What it is? Atomic mass number. Got it? And what is 11 signifies? It signifies the atomic number. Atomic number is nothing but number of protons or number of electrons or number of electrons. Number of protons, you can always call it number of protons. No harm. Number of protons, because the number of electrons always equal to number of protons. Okay. Now, third one. What is the general name of 24Mg12 with respect to 24Na? Many of them will give me a wrong answer. They may call it as an isobar. But see the question. What? They are isobars, no doubt. But what is the general name of this? In magnesium 2412 with respect to 24 sodium level with respect to this. Okay, so naturally I will call it as 24 Mg12 is a daughter nuclide. Daughter, 1 minute. 24 Mg is the daughter nuclide. Okay, please pay attention here. Daughter, Daugchter, nuclide, nuclide. Okay, and this sodium, please have a look at, because they asked with respect to sodium, is nothing but, please have a look here. This is called a parent nuclide. Parent nuclide. Okay, children. I hope everybody's understood this. Okay. Now we go to the next question, children. In this, all right. Okay, this is, I think, more than enough for lecture.